In the previous video, we were able to set up and run the blood unit shipment problem based on the supply and demand of the blood units in 6 cities. Let's move on to the interpretation of results and sensitivity report. Before we move on to that, I would like to make a few notes on this Excel sheet, and I would encourage you to do that with me. A quick review of what we had on our programming space. We had our route set up. After that, we had our yellow cells that represent how many units of blood move between cities. I'm going to go ahead and make a quick note of that. How many units of blood move between cities? And we had cost per route. Blue cells represent actual number of units moved to from cities. And finally, our limits or demand was the inventory multiplied by -1, or it was representing either a city needed units, which was represented by positive number, and if a city could spare units, it was represented by a negative unit. Hence, a red cell represented the limits or demand of blood units. A positive cell represented city must gain that many units, and a negative cell is the amount of units city can afford to spare. Now let's move on to the sensitivity report. Now before we start interpreting the sensitivity report, let's go ahead and color code the cells that are of interest. I'm going to color code the final value, which is exactly the same information coming from our programming space, which are the yellow cells or the decision variables. Final value is the number of units that are being moved through a particular route. Objective coefficient is the unit cost of moving each unit on that particular route. Using allowable increase and allowable decrease, we are going to calculate the maximum cost and the minimum cost per unit that we can afford without changing the final value for that particular route. So our maximum cost per unit is going to be equal to our objective coefficient plus the allowable increase, and our minimum is going to be our objective coefficient minus the allowable decrease. So this maximum and minimum, it gives us the range for our objective coefficient, that how much more we can afford to pay per unit to move through a particular route, how much price we can reduce to move that unit without changing the final value. Or what if the units increase beyond the allowable increase? What's going to happen? Instead of 17, we charge 36. It means that the routes will change in the whole solution, meaning the units need to be shipped from another route to balance the supply and demand that eventually we are trying to balance out. Now, sometimes you're going to see an infinite amount in the max column, which is indicating the maximum price per unit to be used to that route can reach infinite. Now, there can be two possible reasons for it. Either the route is mandatory or the route is not used. So if you see positive final value and an infinite max in this column, that means that that route is mandatory. There is no way to avoiding it. So it doesn't matter how much price is increased to move a single unit through that route is still going to be used. Sometimes you're going to see infinite with 0 final value. That means that route is not being used. Hence, it doesn't matter what is the maximum cost for using that route to move 1 unit through that route. It is not going to affect our final solution. So I'm going to go ahead and write this interpretation down. Now moving on to the constraints table, our final value is the left-hand side of the constraint that we are coding as blue. This is the actual number of units that each city either received or end up sending in total. The right-hand side of the constraint was the actual either supply or demand for each city. The shadow price is the marginal change in the overall objective function due to the change in the right-hand side of the constraint. So let's look at it in a little more detail. So the first thing we have to see is Atlanta had a positive demand. It was in need of 175 units, and it actually ended up receiving 175 units because their final value for Atlanta is 175. A shadow price of 35 means that if Atlanta has to ask for an additional blood unit, it says that we want 1 more blood unit, it is going to increase our overall cost, which is the green cell, the objective function, by 35. If it has to ask, say, that instead of 175, we need 177 units, the overall cost for moving all the units is going to increase by 35 into 2, which is 70. On the other hand, if you see Charleston, which could supply 160 units, ended up actually supplying 150 units, that means that Charleston has a surplus of 10 units because it could spare 160 units and it only ended up sparing or sending 150 units. That means it has still an inventory of 10 units left. This is important information. By comparing the right-hand side and the left-hand side of the constraint in a transportation problem, you can also calculate that at the end of the solution, what is the leftover inventory in the city if they were the suppliers. As you can see, Charleston is the only city with zero shadow price. That means because it could spare additional units, it doesn't matter if we increase the right-hand side of constraint, it's not going to affect our final objective function, which is the total cost of moving blood units from these cities to other cities. The rest of the cities, as they are either meeting their supply limits or demand limits, so they have shadow prices, means that if we increase or if we end up increasing the right-hand side of the constraint for all these rest of the cities, it is going to impact our total cost positively equal to the shadow price based on for which city we are changing the right-hand side of the constraint. So let's do a quick review at the end of the solution. What is the status of supply and demand? And I'm going to make quick notes right in front of each city. Atlanta was in need of 175 units and it ended up getting 175 units, so the Atlanta's demand is met. Charleston could spare 160 units and it only ended up sending 150 units, so we have a surplus in Charleston of 10 units. Louisville ended up shipping all of its units. Mobile has met its demand of 130 units. Raleigh has shipped all of its 125 units. That means they don't have any more units left with them. And Richmond has met all its demand of 70 units. Before we conclude this video, if you look at one route from Raleigh to Atlanta, it says that this route ended up moving 275 units. Now the question to be asked is that Raleigh only had 125 units. How can it ship 275 units? The answer to that question is very simple. That for Raleigh to ship 275 units, it is gaining the units above 125 that it was carrying from some place before it could move. And you have to look at the map to answer that. So for Raleigh to ship 275 units, it's gaining 150 from Charleston. 25 plus 150 is equal to 275. And the same interpretation applies to the rest of the routes. For the route between Atlanta and Mobile, the units that we're shipping is 100. That means Atlanta had 175 units, hence it can ship 100 units. For the route between Louisville and Mobile, final value we have is 30. That means Louisville had 100 units, so it could ship 30 units to Mobile. And finally, for the route between Louisville and Richmond, Louisville had 100 units, so it shipped the rest of the 70 units too. But that's all about the sensitivity report on the transportation problem.